All right, today I'm teaching you how to do combination circuits. So this circuit on the board here is what we're working with. And if you look at this circuit, if you follow the way the current goes, I've got a parallel circuit here, right? Parallel circuit there. I've got these two are in series, right? One after another, because there's only one path goes through there and then comes back out. But these two are in parallel with this first one. So R1 is in parallel with R2 and R3, and also R2 and R3 is in parallel with R5. I'm sorry, 4 and 5. Do you see how it continues? This is one path right here. That's one path, and it comes back here, and this is a path, and so forth. Okay. So what we got to do is the first thing we got to do with the combination circuit is we've got to try to come up with and figure out how can we get one resistor out of this combination circuit. So these two are in series. So what do we do when we add series circuits? So I'm going to turn it red here. We're going to come down here and go, okay, so I come here. I know this. I've already got this parallel one right here. This is 20 ohms right here. This one here is two resistors, right? But to turn it to one, what do? We add them, right? So it's 10 plus 10, so this is 20 ohms. This one here, we've got one there. To turn this into one resistor, we've got the R4 and 5. They're in series, so we add those. So we've got a resistance of 10 ohms here. Okay? So now what does this? Looks like a parallel circuit that you've already learned about, right? So now I can do this with my formula of 1 over RT equals 1 over 20 plus 1 over 20 plus 1 over 10. Well, I know I can do this 1 over 20 plus 1 over 20 plus 2 over 20. And I add them up. I get 2, 3, 4. I get 4 over 20. I got to take the reciprocal of it, so it's going to be 10 over 4, which gives me 5 ohms. Okay? So that means my total resistance is 5 ohms here. That's my total resistance. So now I can find my total current, right? I can find the total current here. My total current is going to be 10 divided by 5, right? That's voltage equals, do our little thing here, right? VIR, voltage, or current equals, voltage divided by resistance. So voltage is 10 divided by 5 is 5, which gives me 2 amps. Okay. What do I know about parallel circuits? I know a parallel circuit is the voltage is whatever the voltage total is. So this is just one. This first one, R1, is just one parallel circuit. So I've got voltage of 10 volts. I know that it's got to be 10 volts here. So we got to have 10 volts here. It's going to be 10 volts down here, and then 10 volts down here. Okay. So now I've got to look at the second set here down here with the red. And I've got to find current. What's the formula for current? Current equals voltage divided by resistance, right? So down here, in this area down here, I'm going voltage is 10 divided by 20 is what? Is 0.5, right? Half. So 0.5 amps. So what does that tell me? A circuit in series is the current is the same, right? So that means this is going to be 0.5 amps, and this one's going to be 0.5 amps. Okay, because we know also in this, now I can do the formula here. So voltage equals 10 times. So voltage equals current times resistance, right? So current's 0.5, resistance is 10. It's going to give me 5 volts. Oh, sorry about that. 5 volts. And down here is the same, 5 volts. Okay, so far so good, right? So we know now down here is 10 and 10, so it's going to be 1 amp, right? So that means I got 1 amp here, and I got 1 amp here. So again, I go 5 times 1 is 5 volts. Well, 5 times 1 is 5 volts. We know that when we add the voltage in a series circuit, so R4 and R5, we add those 5 plus 5 gives me 10 volts, right? This should be 10, the same as down here, because this is the voltage for the series circuit, right? Not the overall circuit, just that part of the circuit. Okay, same thing here. We've got 5 volts plus 5 volts equals 10. We got 10 volts right here. Okay. Does that make sense? Okay, and then so now over here I've got current here, so I've got voltage divided by current, voltage divided by resistance. So I've got 10 divided by 20, which gives me 0.5. I've got 0.5 plus 0.5 plus 1 gives me 2 amps, which is my total current. All right, so let me go back to the assignment then that you're going to be working on. And I'll pull that up so you can kind of see it and get an idea of what we're doing here. me open it up. Hold on a second. I just got to go to it here. Sorry, just for to do that, I'll go back to my. I thought I had it open here. Yes, I did. Some of the electronics. Okay, so in the assignment, I think they're slow right now. Circuit assignment right here. Oops, wrong one. That's the reading. This one right here. Open up this here, and I'll zoom in here. Okay, so if you look at this circuit here, this is your assignment that you're working on. Okay, so I've got basically series circuit. So when I add this one here, let me do the first three for you. So here's my resistance, 5 ohms, 5 ohms. We know that those two together are 10 ohms. And now here we've got the 1 over RT equals 1 over 3 plus 1 over 3 plus 1 over 3. That equals 3 over 3. I take the reciprocal, I flip it, right? It's still 3 over 3. So that means 1 ohm. So these three resistors right here are 1 ohm. That's my parallel. So now right up to this point. Now up to this one here is R3, 4, and 5. So this is R3, 4, and 5 together, right? Does that make sense? Those three are together, right there. And if I take those, I go. So I write at this point. I got 5 plus 5, 5 plus 5, which is 10, plus 1, which is 11. So I'm figuring out my total resistance. And I've got these two here, 10 and 20, right? So it's going to be 1 over 10 plus 1 over 20. So it's going to be 2, 10, 3, 20. 20 divided by 3, whatever. And then that's that resistor, and so forth. I figure out all of that. I figure out all of these right here, all the parallel circuits, and all these. Find out the resistance. Then I just go across and add. So I add this plus this top one here, plus this one here, plus this one here. It's going to be around 50, somewhere around in the 50 to 60 range ohms. Okay, that's what you should end up with. Once I figure that out, I do my total current. So my total current is going to be whatever. So my total resistance. So it's going to be voltage 100 divided by whatever the current is. It's going to be in the one amp range. Once I know that this amperage is my total amperage. This is my total amperage. Now this up here is my total amperage. Up here, not this. I've got to first figure it out up there using that 1 ohm resistor right here. Once I do that, whatever the current is, I move that current down to these three locations here, and then use my use my voltage V, right? V equals IR for this one here. Oh, different color here. For this one here, and this one here. Once I take this current up here and bring it down there. Does that make sense? And you do that for each parallel circuit, and then that's how you figure it out. So basically, you bring it together. Then you break it back out again to figure out the voltage drop from each, the current, because we know the voltage is going to be the same. Because the current here is going to be the 1, and we do the voltage. Bring the voltage from here down to these locations, and then we do the current equals voltage divided by resistance, and that's the formula we use for those three to find the voltage, the current through each parallel circuit. Hope that helps. It makes sense. If not, ask me when you come back, or when I'm back, whenever, and I can help you out that way. Okay.